planet, which is not a really good place to be. Just isn't. Cosmologically speaking, surfaces of planets are highly unstable. They don't just hang out because there's people on it. Our atmosphere is equivalent to, like, if you took a billiard ball and put a little shellac on it. That's about the thickness of our atmosphere. And the Earth beside the Sun is like a little grain of sand. A teeny weeny grain of sand. And one of those big sun flare comes out in the right place at the right time, and and everybody in the solar system goes, huh, what was that? Oh, that was Earth's atmosphere. All done. Next thing you know, it looks like Mars. Right? So, never mind, you know, asteroids and comets and all the rest of the stuff. Right? So there is typically a cosmological time period in which a civilization like ours has to figure out how to get off their rock. And if they don't on time, well, you know, on to the next round. You see what I'm saying? This is a fundamental step that a civilization must do. And we are at that point. We are at that moment in our evolution where we must understand these more fundamental principles of the physics of the universe. That includes the philosophy of the universe, the spirituality of the universe, the connection that connects us all, and understand how it works and apply it in our technology so that we can actually, literally ascend. So, after all this rant, if I use 10 to the minus 39% the mass of the mass of the vacuum to make the atom an uni black hole, all of a sudden my atom is a heck of a lot heavier than the atom that's measured in laboratory. So the mainstream is really not happy with that. You can imagine. In fact, my atom is 10 to the 39 orders of magnitude larger than the standard proton. So, you know, you would think, oh my God, it's got to be wrong, right? 10 to the 39 orders of magnitude wrong. Right? Well, the first thing I did, I said, well, if I'm that wrong, this, you know, it shouldn't work in a scale. So I took a scaling law. This time I took the mass against the radius, and I put all the objects in the universe I could find. You know, universe, this is the Planck's mass, the Planck's distance, and then, you know, galaxies, quasars, the sun, the earth, pulsars, and this is the Schwarzschild proton, this is the black hole proton, and this is the standard model proton. So, you know, this is straight off data. This is not really debatable. Obviously, this data point is in the wrong place. Why is that? It's because our way of measuring the mass of the proton, and just so you know, in physics, mass has not been defined. They don't tell you where it comes from. Right? Is to knock the proton out by shooting particles at it. And then it pops out of the atom, and then we make a measurement, and we assume that the proton was the same mass when it was in there. Well, you know, when you've disturbed the system, you probably don't get the right data. It's the same thing in you probably don't get the right data. It's the same thing in biology. You know, we want to study cells. So what do? We freeze them with liquid nitrogen. And then we shear them open. Now they're not alive anymore, you know. And then we look with an electron microscope. And, oh wow, you know, DNA is a big mess in there. We're probably not getting the right data. And so, why is it that, I just want to make a point, that this excess mass is because it's actually in the mainstream theory, it's just they don't know about it. And the reason why is because when they found 2 protons, they said, oh my God, protons are positively charged, so they should repel each other inside the nuclei, like 2 magnets would repel each other if they have the same charge, right? You're all following this? Well, when they found this, they said, oh, you know, gravity couldn't squeeze them that hard. There must be some unknown force. And the next thing they did is they invented a new force almost 100 years ago. They called it the strong force. Very convenient. And then they put it in there and they made it exactly the strength it needed to do to push the protons together. Huh. I call that physics as you go. They did the same thing with the universe. They found their equation only predicts 4% of the universe, missing 96% of the universe. Instead of revising the equation, they said, oh, we'll invent dark matter and dark energy, throw it in there in the right percentage. Look, the equation works. Must be there. Physics as you go. Right? So then, you know, when they invented this strong force, then the next thing you know is they can't reconcile the strong force with gravity. They can't put the two together. Right? So now they have this big dilemma, and now they keep adding dimensions to try to make it work. You know? It ain't gonna work because the strong force does not exist. It's a figment of our imagination. It's gravity acting at the atomic level. You're dealing with mini black holes. That's why the electron spins at near the speed of light. Right? So, if you take 2 of these protons, little black hole protons, and you calculate their strength, I'm going to spare you the equations. Although you could easily follow them because they're simple. The force between 2 black hole protons is very large, so it can overcome the repulsion. But then you calculate how fast 2 protons like that with that force would rotate around each other. And you find that you know, they rotate at very high speed, 10 to the 32 centimeters per second square, very rapidly. And then you calculate, that was their acceleration, you calculate their velocity, and V turns out to equal 2.9 multiplied by 10 to the 10 centimeters per second. Anybody recognize that number? Very good. The speed of light. V equals C. So now, these little protons at the center of the atom are not only infinitely dense, but they're spinning at near the speed of light. They're spinning at very high velocity, near the speed of light. So you know all these masters that walked around saying, you are light? They meant it. Can you like visualize yourself? Can you sense yourself? Can you sense your atoms as mini black holes spinning near the speed of light? This is how dynamic you are. This is how energetic you are. It's an amazing thing. You're transferring information to the universe and back at the speed of light. You're flickering. really, really quickly. Push the vacuum, to the vacuum, back out, to the vacuum, back out, to the vacuum, back out. So who are you when you're the vacuum? Have you explored your vacuum self? You know, please don't talk to your shrink about this because it might put you some nasty drugs, you know. Bro, you're bipolar. Yes, I am. I'm sorry, but half the time I'm the vacuum. I don't think they have any drugs to stop that one. So, you know, I can skip some of that, but I just wanted to say, you know, you're flickering, you're informing the vacuum, flickering in and out of it very, very quickly. Everywhere is happening like this, you know. It's, my 4-year-old actually talked to me about that once. But, you know, it's really a remarkable thing, and it's really important to become aware of this interaction. And when it's happening, you start to realize that maybe linear motion is not quite what we think it is. And what I mean by that is that if we live in a fractal universe of infinite division, from infinitely big to infinitely small, then movement from point A to point B is quite different than what we assume it is. Okay? You can start to look at your hand and say, okay, my hand is going from point A to point B. And I'm going to calculate how fast it did that. Well, you know, if you close the box around your hand, then you can do it. But if you realize that it's all embedded to infinity, then you'd say, well, while my hand was going from A to B, the Earth was rotating. So I got to add that speed. And then while that was happening, the Earth was rotating, then the Sun, it was rotating around the Sun. So I got to add that speed. And then as it rotated around the Sun was moving through the galaxy. So I got to add that speed. So you know, your hand is now moving at millions of miles per second, you know. And then like, you know, you keep adding because this galaxy is in a supercluster, which is in a in a cluster, which is in a supercluster, and so on. In a universe, in a multiverse. Next thing you know, your hand's going at the speed of light. So how do you define movement? You realize that your hand is not moving linearly from A to B. That's the chopper that likes to follow me. Your hand is appearing, disappearing, appearing, disappearing, undoing itself, redoing itself, undoing itself, redoing itself, every time going to infinity and back. Being informed of where it must reappear. Just like a movie, which is a bunch of frames, but if you move the frames fast enough, they appear to be smooth. And if you realize that, you're interacting with the vacuum this way, and you're good at manipulating the vacuum, what I call vacuum engineers, masters,